This video is going to be about carbohydrates, our first biological macromolecule. Carbohydrates are made of carbon, hydrogen, and oxygen. So of N-CHOPs, they make up this CHO of N-CHOPs. These elements come in a 1 to 2 to 1 ratio. So for every 1 carbon, there will be about 2 hydrogen and about 1 oxygen. Now this isn't always the case, but it's going to be pretty similar to this. And so for example, glucose is a big example of this. You see you have 6 carbon, 12 hydrogen, and 6 oxygen. So it's still that same 1 to 2 to 1 ratio. Carbohydrates range from small sugar molecules, which are going to be the monomers, to very large polysaccharides. So sugar monomers are going to be called monosaccharides. So again, we hear that mono prefix in the monomer, and then anytime you hear saccharide, you should be thinking carbohydrate. Monosaccharides are going to be things like glucose and fructose. And you should note that many basic carbohydrates, their names will end in ose. That OSE, glucose, fructose, sucrose, lactose, things like that. Now, it's not a rule, but if you see that ending ose, you could guess with a good certainty that it will be a carbohydrate for our purposes. 2 monosaccharides coming together forms a disaccharide. So this would be the dimer, where you have 2 monomers together would be a disaccharide, and then a polysaccharide would be the polymer of carbohydrates. So notice that we are constantly getting those prefixes, monosaccharides in the monomer, disaccharides in the dimer, polysaccharide for the polymer. And notice here that carbohydrates, here we have 2 glucose monomers linking together to form a dimer of maltose, again ending in ose. And notice here we are using that dehydration synthesis reaction. We are removing water and then bringing this bond together. And just as an advanced term, a typical covalent bond between carbohydrates will be called a glycosidic linkage. And of course, this is a covalent bond. Carbs, sort of a shortened word for carbohydrates, carbs can be found in rings or chains, which we know that carbon is really good at forming. And so we already saw like glucose had sort of a ring like that, and then maltose was basically a chain of rings, and we'll see more polysaccharides like that in a moment. Carbohydrates have multiple functions in your body, and these are some pretty basic functions, but they are involved in the structure of certain items. So for example, carbohydrates will be involved in the cell walls of plants, creating structure. Simple monomers like glucose will be involved in getting quick bursts of energy. If you think you have candy and sugar, quick bursts of energy. And also, complex polymers can be involved in long-term energy storage, sort of the reason that runners will have pasta parties and get those complex carbohydrates into their systems, not an hour before they run, but some amount of time before they run, so they have all that stored energy. Here are some examples of polysaccharides you might have or might have not heard of. You need to know one of these for plants and one of these for animals. Starch is a storage polysaccharide composed of glucose monomers and is found in plants. You will see starch, for example, in potatoes. Potatoes are literally storage centers for starch for plants. They're storing energy that they've made. Glycogen, this is the big one for animals. that is a storage polysaccharide of glucose. Again, glucose is the monomer for a lot of these, which is created in animals when, or which is hydrolyzed, right? Get that hydrolysis. So it's broken down when glucose for energy is needed. So glycogen is going to be energy storage in animals. Cellulose, again we have this ose ending, is a polymer of glucose that forms plant cell walls. So this is that structure function for plants. And this is pronounced, interestingly, this is pronounced chitin. And it's a polysaccharide used by insects and crustaceans to build an exoskeleton, a skeleton that is on the outside. Exo, think exit or exothermic reactions or something like that. Okay, chitin is also used by fungi for their cell walls, interestingly enough. So here's some pictures of polysaccharides just to sort of see. You have these little glucose monomers, and they have been attached to each other to form these very long chains. So in all of these polymers, we have chains of rings connected to each other, and of course all of them are connected via glycosidic linkages, which are basically covalent bonds between carbohydrates. And so these are the questions you should be able to answer about carbohydrates after watching this video. And if you have trouble answering any of these, I would go back and look at the video again.